All right, let's look at 3b. So you've got r of lambda, so let's just write that as xi plus yj is equal to 2 sec lambda I plus tan lambda j. Get it all written there. Right, equating coefficients, and you'll have x is equal to 2 sec lambda. Y will be equal to tan lambda. So how do we combine sec and tan? Well, we're going to need the trig identity again. So sine squared, I'll use lambda, doesn't matter what I use, plus cos squared lambda equals 1. So to get a tan and a sec, I'm going to need to divide everything by cos squared. So sine squared divided by cos squared will give me tan squared lambda. Cos squared divided by cos squared will give me 1. 1 divided by cos squared will give me sec squared lambda. So if I square this, because I'm going to need to square them, that's going to give me 4 sec lambda. And so sec lambda will equal x squared on 4. And, well, tan lambda is going to be equal to y, so we'll just leave that one as it is. Now, go back to your trig identity, a little star there. We want to get, we're going to make that, if we keep the 1 on this side and move the tan squared across, we will have sec squared lambda minus tan squared lambda equals 1. So replacing the sec squared, looks like I left out the squared, and actually might square this one, make that tan squared lambda. So sec squared lambda is x squared on 4. Tan squared lambda is minus y squared, and that's equal to 1. Now hopefully you remember, oh yeah, that's a hyperbola. Remember, it's got the minus sign between the two of them. A is the value that's under the x, so a is equal to 2, because remember it's a squared on the bottom, and we might put that one on 1. So b will be equal to 1. And your asymptotes, good little revision here, your asymptotes are given by y is equal to plus or minus bx on a. So in other words, y is equal to plus or minus, b is 1 and a is 2, so that makes that a half x. So now we can sketch out our hyperbola over here. Mark in your asymptotes. So y equals x on 2, or a half x. Y equals minus x on 2. Beautiful, x, y. Okay, now which side do they go? So if you're not sure, just work out the, you'll either get x-intercepts or y-intercepts, you won't get both. So if we do the x-intercepts, we would make y equal to 0, and if you make y equal to 0 in your Cartesian equation, you'll have an x squared on 4 is equal to 1. So x squared will be 4, so x will be plus or minus 2. So there we know it goes through 2, 0, so minus 2, 0. And we know it also will go through 2, 0. So it's got to be the ones that are in this part, the ones that are actually in the acute angle. Not easy to draw here on the side. I'm sure you can be much smoother than I can. All right, so that will give you your hyperbola. Notice if you tried to find y-intercepts, you would have said, okay, if y-intercept x is equal to 0, so you would have then had minus y squared on 1 is equal to 1. So y squared would have equal to minus 1, and obviously you can't take the square root of a negative number. All right, so watch the domain. Okay, so your domain is given from your is given from your graph here. So your domain is minus infinity to -2. That's inclusive. That's not union. 2 to infinity. Okay, and your range. Well, if you follow either of those curves down, they're going to go to infinity. So it's probably just y as an element of reals is the easiest way to do that. Notice y is equal to tan lambda. So if you graph tan lambda, if we do a graph of tan lambda, tan goes like that, of course. So you can see that your domain goes to your domain is in negative infinity to positive infinity, or reals. Thank you.